Come on. Do this question better. The equation of state for 5 gram of oxygen, 5 gram of oxygen at pressure P, and temperature T, and temperature capital T, when occupying a volume V, when occupying a volume V, occupying a volume V will be dash. First option is PV is equals to 5 by 32 R into T. Second option is PV is equals to 5 by 2 R into T. Third option is PV is equals to 5 by 16 into R into T. And fourth option is PV is equals to your 6 R into your T. So try it. Can anyone give me the answer for this one? The equation of the state for 5 gram of oxygen at a pressure P and temperature T when occupying a volume V will be equal to your how much? One step answer. Option A. Very good. So what is the formula, beta? PV is equals to N into R into your T. N is equals to what I told you? Mass by your molecular weight. Mass is how much for me? 5 grams. This will be equal to 32 grams. So this will be equal to 5 by 32. So P into V will be equal to 5 by 32 R into your T. This will be the answer. First option will be the answer. Clear, beta? Sure, next question. At 10 degrees centigrade, the value of density of a fixed mass of an ideal gas divided by its pressure is X. At 110 degrees centigrade, this ratio is, come on, try it better. First option is 283 divided by 383 into your X. Second option is X. Third option is 10 by 110 into your X. And fourth option is 383 divided by your 283 into your X. Come on, try to do it better. Got it, beta? Anyone? At 10 degrees centigrade, the value of the density of a fixed mass of an ideal gas is divided by its pressure is given as of your x. At 110 degrees centigrade, the ratio is equals to your how much? Done. परीक्षा करना. Write the value in terms of density, beta. Write the value in terms of your density. At 10 degrees centigrade, the value of density is equals to your density of a fixed mass of an ideal gas divided by its pressure is equals to your x. That means if PV is equals to your nRT, PV is equals to N into R into T. So it is P into V, N is equals to mass by your molecular weight into R into T. Density is equals to mass by volume. So I can write here P is equals to mass by your volume into capital M into R into T. Mass by volume can be taken as of your density. So P is equals to rho into your RT divided by capital M. So from this one I can write density. Density is equals to your P into your M divided by R into your T. So this is the formula for density. In the problem is telling ratio of what, beta? 10 degrees centigrade, the value of density of an ideal gas divided by its pressure is equals to your x, isn't it? At what temperature? At your 10 degrees centigrade. Then density by your pressure is equals to, say for example, y at your 110 degrees centigrade. Then this ratio will be equal to how much? That means x by y is equals to how much? So I can write here x will be equal to how much, beta? M. Molecular weight is nothing but of your M divided by R into temperature. Temperature is how much for me? 10. 273 plus 10. It will be your 283. And y will be equal to your M divided by your capital R into 110 plus of your 273. That will be equal to how much, beta? 383. Okay. So it's asking the ratio of what, beta? The ratio of this value will be equal to your how much? Can anyone tell me? This ratio is asking. Ratio means y value. Okay, y by x, anything. So y by x is equals to how much? Y by your x. Y value is M divided by your R into your 383 divided by x. X value is how much we got, beta? M divided by R into your 283. This M will get cancelled. This R will get cancelled. So y by your x is equals to your 283 divided by your 383, isn't it? So ratio will be equal to your 283, or else y will be equal to your 283 divided by 383 into x. That means first option will be the answer. Clear, beta?
Yes, sir.
Clear? Next one. Kinetic gas equation. Yesterday I told you, beta. Kinetic gas equation. What is the kinetic gas equation, beta? Can anyone tell me? Yesterday I told you this one. What is the kinetic gas equation? P is equals to your 1 by 3 into your M into your total number of molecules N into your Vrms square divided by your V. V is your volume. P is equals to your 1 by 3 m into your n into your Vrms square divided by V. V is your volume beta. V is your volume. Fine. Clear beta? Sure. What is m here beta? Mass of one molecule of gas. M is equals to mass of one molecule of gas. Mass of one molecule of your gas. Then n is equals to what here? Number of molecules of gas. Number of molecules of your gas. V is your volume and P is nothing but your pressure and Vrms is nothing but of your root mean velocity. Vrms is nothing but of your root mean square velocity. Okay. Now see, for 1 mole of gas, if I'm writing, for 1 mole of your gas. So for 1 mole of your gas particulation, N will be equal to your Avogadro number. So P will be equal to your 1 by 3 into your M into Avogadro number into your Vrms square divided by your V. So this is mass into your Avogadro number will represent for me your molecular mass bit. So M is equals to your total mass of the gas will be equal to your M into your Vrms square divided by 3 into your V. M is the total number of molecules of the gas bit and V is your volume here right now. Okay. Small m into Avogadro number will give me the total number of your molecules. That means I can write from this one, P into V will be equal to, PV will be equal to your 1 by 3 into M into your Vrms square. Or else I can write here, PV is equals to your 1 by 3 into your 2 into your, I'm dividing and multiplying with your 2. This is half into your M into your Vr square. M into your Vrms square. So that will represent me kinetic energy. So this will be your 2 by 3 times of your kinetic energy. So this will be equal to your PV. This is also one more important form of your ideal gas equation part, kinetic gas equation part. That means I can write here kinetic energy of 1 mole of your gas. 1 mole of your gas will be equal to 3 by 2 times of your pressure into volume. 3 by 2 times of your pressure into volume. Clear? For 1 mole, we know the relation PV is equal to how much beta? nRT. For 1 mole, PV is equals to your N into R into your T. So N is equals to 1. So PV is equals to R into T. So therefore, kinetic energy will become for me 3 by 2 into your R into T. That means I can say that kinetic energy of the gas is directly proportional to your absolute temperature. Okay. So for N moles, if I am writing, for N moles, kinetic energy of your gas, kinetic energy of your gas will be equal to 3 by 2 into N into your R into your T. This will be the answer. Clear, beta? Next one. For 1 molecule of gas, for 1 molecule of your gas, how do you write the relation, beta? Can anyone tell me? For 1 molecule of the gas, if I am writing the relation, so that will be equal to your divided by your Avogadro number. So kinetic energy for one molecule will be equal to your kinetic energy due to 1 mole divided by your Avogadro number. That means I can write here kinetic energy of your one molecule will be equal to your, this will be equal to your kinetic energy is how much we got beta right now. Kinetic energy will be equal to, for 1 mole of a gas, it will be equal to your 3/2 into your R into your T. For 1 mole of a gas, if I am writing 3/2 into your R into your T. So it is 3/2 into your R into your T divided by your Avogadro number. This R by your Na will give me what beta? Boltzmann's constant. So it is a 3/2 into your K into your T. Okay. So I can write here, for your translational energy particulation, kinetic energy will be equal to your, this will become for me your F/2 into your K into your T. F is nothing but what? Number of degrees of freedom. F is your degrees of freedom. Okay. So kinetic energy for 1 mole of a gas in terms of degrees of freedom also I can write as of your F/2 into your K into your T. For monatomic gas, it will be 3. Diatomic gas, 5. For triatomic gas, it will be your 6. Like that, we can go on write the relations for that. Okay. So these are the some of the standard formulas of your kinetic gas equation. P is equals to 1/3 m into n into Vrms square divided by V, where m is your mass of one molecule of a gas, n is your number of molecules of the gas, and Vrms is nothing but of your root mean square velocity. For 1 mole of a gas, if I am writing right now here, for 1 mole of your gas, if I am writing the relation, for 1 mole of your gas, it will be equal to how much for me? But n will be equal to your Avogadro number. Then, so if I am simplifying that one, for 1 mole of your gas, kinetic energy of the gas will be directly proportional to absolute temperature, and for n molecules or n moles, if I am writing 3/2 into your n into your RT. Then for 1 molecule of gas, this will be the answer. Just a minute, beta. Different types of your gases velocities. In the bracket I am writing beta. Velocities. First one, Rms velocity. I hope you remember the formula for the Rms velocity beta. Can anyone tell me what will be the answer beta? Root mean square velocity, Vrms, will be equal to, this one is your root mean of all and square of the velocities. That is nothing but if your V1 square plus V2 square plus V3 square plus so on up to your Vn square divided by mean. Mean means whatever the number you are writing, that value. Clear? Example, if speed of 5 molecules are 2, 3, 4, 5, 6. The RMS velocity of this one is how much? The RMS speed for these molecules is, can anyone tell me the answer beta? We got how many molecules? 5 molecules. That means Vrms will be equal to under root of your, this will be equal to 2 square plus 3 square plus 4 square plus 5 square plus 6 square divided by mean. How many? 5. So that will be equal to under root of your 2 square is 4, 3 square is 9, 4 4 is 16, plus 5 5 is 25, plus 6 6 is 36, divided by your 5. So that will be equal to, this one is 4 plus 9, 13. This will be equal to 26 and 28, 20, 40, 48, 14, 50, 53, 60, 70, 80, 90. So this will be equal to under root of your 90 divided by 5. So that will be equal to 5 ones are 5, 6, 7, 8, 4, 5 8s are 40. That means it will be root 18 meter per second. Clear, beta? Is that clear? Chalo. Next one. RMS velocity of gas molecules. RMS velocities of your gas molecules. See this one. First one. Vrms will be equal to under root of your 3 into RT divided by molecular weight. Kepler value is 8.3 joule per mole Kelvin. T is in your kelvins, absolute temperature. And capital M is nothing but of your molar mass in your kgs. Okay, capital M is your molar mass in your kgs. Or else if I'm writing Vrms like this, Vrms will be equal to under root of your, this will become for you 3 into your K into T divided by your M. Here M is nothing but of your mass of one molecule. Mass of your one molecule in your kg. And K is your Boltzmann's constant. 1.3 into 10 to the power of 23. Okay, so what are the formulas? Under root of 3RT by your M and under root of your KT by your M part of your lambs. In terms of your density, if I'm writing, in terms of your density and pressure, in terms of density and pressure, we already know the formula, but density is equals to PM divided by RT. Today PM is in Telangana. So you can remember PM divided by your RT. That means I can write here R into T divided by molecular weight will be equal to your pressure divided by density. So therefore I can write here Vrms will be equal to under root of your, this RT by your M can be written as of your 3P divided by rho. 3P divided by your rho. So this is your Vrms formula. So Vrms will be equal to your under root of your 3P divided by your rho. So these are the three standard formulas which you need to remember for the Vrms velocities. Vrms is equals to under root of your 3 into your RT divided by molecular weight, or Vrms is equals to under root of your 3KT divided by your M, or Vrms is equals to under root of your 3P divided by your rho. Is that clear? Sure. Let me do one question for you. Write this question better. What will be the temperature? What will be the temperature when the RMS velocity, is double that of 300 Kelvin. Double that of 300 Kelvin. See, in the app I already have been uploaded 2 assignments with on KTG. So please try to go through it, and today also on the WhatsApp I'll try to send you the 2 assignments at any of. Okay, what will be the temperature when RMS velocity is double that of your 300 part of relation? Can anyone tell me the answer better for this one? What will be the temperature when RMS velocity is double that of your, double that of, now it is double that at 300 Kelvin. That means Vrms is equals to 2 times of your Vrms at your 300 Kelvin. That's what he's telling. That means this is your under root of your 3R into your T divided by your capital M is equals to 2 times of your under root of your 3 into your R into temperature is your 300 divided by capital M. This capital M, this 3R, this root will get cancelled. So if I'm cancelling the root, this will be equal to your T is equals to 4 and this will become for me 300. So 4 3s are 12. So this will become for me 1200 Kelvin. Root 2. Clear, beta? So next question. See, beta. The RMS speed of oxygen molecule in a gas at 27 degrees centigrade would be given by first option is 483 meter per second, second option is 966 meter per second, third option is 4.83 meter per second, and fourth option is 9.66 meter per second. Chalo, try to do it better. The RMS speed of the oxygen molecule in a gas at 27 degrees centigrade. Temperature will be equal to 27 degrees centigrade. Convert that one into Kelvin. 27 plus 273. So this will be equal to your 300 Kelvin. So Vrms will be equal to under root of your 3 into R into T divided by your molecular weight. So that is equals to under root of your 3 into R value is 8.3 into absolute temperature is 300 Kelvin divided by molecular weight of oxygen will be 32 grams into the kgs, that is 10 to the power of minus 3. Okay, so if I'm doing this calculation, this is approximately, I can take it as of 8 beta. So it is your under root of your 3 into your 8 into your 300 divided by 32 into 10 to the power of minus 3. So this will be coming how much right now for me? 8 1s are 8 4s are 32. So that means this will be equal to 3 into 3. This will be 9. So it is 900 divided by 4 into. So this will be 10 to the power of minus 3. 3 will be equal to how much right now for me? This is 2. So that will become for me 1000. Clear, beta? Is it clear? Okay, so this is gone up, so it will be your 300. So this is totally into the root. That means this will become for me 30 divided by 2 approximately. Into this will become for me 10 into root 2. That means this will be equal to 30 into 10 divided by 2 into root 10 approximately. I can take nearby value beta. So it will be a root 9. So root 9 will be equal to how much for me? 3. So it will be equal to 30 into 10 divided by 2 into your 3. So it is 2 1s are 2 5s are. So that will be 3 3s are 9, 9 5s are 45. That means 450. So approximately 450, that will be equal to first option. Clear, beta? Is that clear? Sure. Next one. What is the next type of a velocity beta? Did anyone remember that one? Average velocities. Molecular velocities, if I'm taking right now, the next one is about your average velocity. Average velocity. Like in kinematics, will write V average. V average. So it will be your V average will be equal to your V1 plus V2 plus V3 plus so on up to your Vn divided by your n number of your molecules. So V average is equals to your under root of your 8R into your T divided by your pi into your capital M. That is equals to under root of your 8K into T divided by pi into your capital M. That is under root of your 8P divided by pi into D. You need to remember this one better. There is no other alternate for this one. So the more you practice, the better you can remember this one. Otherwise, there are the chances that you forget of them. The next one is about your most probable velocity. Most probable velocity. Most probable velocity. Represented by your, that means it is a molecule. Most probable velocity means maximum number of molecules or maximum fraction of molecule possessing this velocity. Maximum fraction of molecules possess this velocity. So the number is larger. So V most probable speed will be equal to under root of 2 into RT divided by capital M. That is equals to under root of 2K into capital T divided by capital M. That is equals to under root of 2P divided by your density rho. Here D is nothing but density. And P is nothing but pressure. Clear? So we got three types of velocities: Vrms, average velocity, and most probable velocity. And this one, the graph is very important, beta. So let me draw the graph for this one. Maxwell's speed distribution law. Actually, it has a very good concept, beta, but at this stage, it is not required. Directly try to remember the graph. We get only the questions based on the graph on this one. That part only you try to remember. This one is along your x-axis and this one is along your y-axis. So if I'm writing the quantities, this is here I'm writing your fraction of molecules. That means dn by your dv. So maximum number of fraction of molecules will be something like this. Okay. So in this one, if I'm taking this graph here, this one. Maximum number of molecules is being possessed by your V most probable velocity. This will be most probable velocity. This will be your V average and this will be your Vrms. So the graph, the molecules which have been present in lesser molecules will be your Vrms. The next lecture is V average. That means I can write that RAM, you try to remember better. RMS velocity, that means Vrms is greater than of your V average. V average, that is greater than of your V most probable velocity. Okay, so if you remember the shortcut RAM, that will be more better to remember the increasing and decreasing order. That means this will be equal to root 3 greater than root of your 8 by your pi will be greater than of your root 2. So I can write here root 3 is greater than root of your 2.5, which is greater than of your root. Clear, beta? So this ratio you try to remember it. So it is root 3 greater than of your root of your 2.5, which is greater than of your root 2. That means V most probable is greater than of your V average, sorry, Vrms now. Number of molecules will be more for your, what do you call that one? Most probable. So velocity of your RMS velocity is greater than of your average velocity is greater than of your most probable velocity. Clear? I already told you mean free path particulation. You can try to remember that one and try to do the relations for this one better. Okay. So this one was some of the important formulas you need to remember. There was a question once in the NEET. I'll just give it, see whether you can see it, do it or not. Not NEET exactly. NEAT is a direct formula based question. Once we got on this one, how to calculate the mean free path, the definition right now. See this question better. The mean free path of molecules of a gas. Okay, the radius of this one is R, is inversely proportional to Can anyone tell me better? First one is R cube, next one is R square, third one is R, and fourth one is root R. Can anyone give me the answer? The mean free path of the molecule of a gas R is inversely proportional to anyone. What is the formula beta? Lambda is equals to 1 by under root of your 2 into n into pi into your d square. Okay, so diameter will be equal to how much beta? 2 times of your radius. So d square means it will become for me 4 into r square. That means wavelength is inversely proportional to your d square. Okay, that means lambda will be inversely proportional to your d square means 4 into your r square. That means lambda is inversely proportional to your r square. Is inversely proportional to r square. Second option will be the answer for that. Clear, beta? This was directly asked once in NEAT 2020. In NEAT 2020, this was a direct question which has been asked in the KTG part of question. Clear, beta?
Yes, sir.
Saturday mania is on my head. Okay, so almost all the formulas have been covered. We'll try to do the remaining part of this one, not remaining. The next topic of this one is thermodynamics in detail related to your all the processes. And I've already sent you some of the assignments. Let me send you right now only the assignments. Just see whether you're getting it or not. KTG, I've got 2 assignments with me, Veda. Did you get it, you see, Veda, in your WhatsApp? Did you get it, Veda? So please try to complete that KTG problems better. Even fluid mechanics questions in this weekend syllabus, what are the topics there? I'll try to send you this also. You try to see it whether you're getting them or not. I don't know if I'm having it right now or not. I'll just see it out. Okay, chalo, I'll send it out better then. Okay, take care. Bye.